This is Module 1, Lesson 8. In this lesson, we're going to round multi-digit numbers to any place value using the vertical number line. So let's draw our vertical number line as we did in the last lesson. Except this time, we're going to round a 5-digit number. And we're going to put 70,000 at the low end of our number line and 80,000 at the high end. And we're going to round the number 72,744. So as we've done before, we're going to find the midpoint between 70,000 and 80,000, which would be 75,000. And we're going to see where this number would fall in the number line. Is it going to be between 70,000 and 75,000 or between 75,000 and 80,000? And we're going to round to the nearest 10,000. Remember, we can round to any digit in the number, so we always have to specify which digit we're rounding to. So we're rounding to the 10,000. So we started our number line with 70,000, since there's 7 10,000s in the number we're rounding to. And the next highest 10,000 would be 80,000. And if we look at the next digit, we see this is 2,000. So the thousands digit here is 0, and then 5, and then 0. But it's 80,000. So we have 70,000, 75,000, 80,000. So 72,000 would fall between 70,000 and 75,000. And if we're rounding to the nearest 10,000, we have two choices. It's either closer to 70,000 or closer to 80,000. And we see where it is on the number line. It's closer to 70,000. So 72,744 rounded to the nearest 10,000 would be 70,000, since it's closer to 70,000 when we look at it on the number line. Let's look at a different one. This time we're going to look at a 6-digit number. So instead of starting with 70,000, we're going to start with 700,000. And our high end would be 800,000. The number we're going to round is 749,085. And as usual, we're going to find our midpoint. So halfway between 700,000 and 800,000 would be 750,000. And if we look at the rest of this number here and compare it to the other numbers that we have, we'll see that 749,000 would be just less than 750,000. So it would fall here on the number line, just short of our midpoint. So again, even though it's close, if we were going to round to the nearest 100,000, then the nearest 100,000 would be 700,000. Since it's a little closer to 700,000 than it is to 800,000. Okay, let's use this to help us with another kind of problem. We're going to look at an addition problem. $505,341 plus 193,841. Now, when we start doing operations on large numbers like this, it's easy to kind of get lost in the process sometimes. So a good strategy is to estimate what the sum is. In other words, to find a number that's very close to the sum, even though it's not exactly the same. And we do that by doing what we've been practicing, which is rounding. So we're going to start by rounding each of these numbers to the nearest 100,000. So we're going to round to the nearest 100,000. Okay, so we're going to look at this number first, and we already have 500,000. The next highest 100,000 would be 600,000. So if we look at what's left in the rest of the number, we can try to visualize this without actually drawing the number line. If you need to draw the vertical number line, that's fine. But if you can start to visualize the number line without drawing it and skip that step, that's okay too. So one possibility that we can round to the nearest 100,000 is 500,000. This is only 5,341 away from 500,000. The next 100,000 would be 600,000. And this number that's left is a long way from that 600,000. If we think our midpoint would be 550,000, so our midpoint would be 550,000, we can see that this number would fall between 500,000 and 550,000 because our next number is going to be 600,000. So this number would fall in here. So we would round to 500,000. Now let's do the same with this number. Again, we're rounding to the 100,000, so we have 100,000 here. But if we look at the rest of this number, and we think the next highest 100,000 would be 200,000, and it already has 100,000, and we think, where would this number be closest to? Is it closest to 100,000 or 200,000? And if we see our midpoint would be 150,000, we can see that this number is much closer to 200,000. So we would round this number to 200,000. So our estimate of the sum of these two numbers, rounding to the nearest 100,000, would be 700,000. Let's actually add these two numbers together. And see how close our estimate is. And so this would be our actual number that we would get if we added the two together, 699,182. And our estimate is very close to that. So if we estimated this and then got this as an answer, we'd be pretty confident that our answer was correct. Okay, so let's try a different one. Let's try a subtraction problem this time. Let's say we're going to subtract 35,555 minus 26,555. And we're going to start by rounding to the largest place value. So the largest place value here is the 10,000. So we're going to round to the 10,000s. So I have three 10,000s here, 30,000. The next higher up would be 40,000. My midpoint would be 35,000. So this is close, but it's a little past the midpoint. So if I round to the nearest 10,000, I would round to 40,000. And for 26,000, it already has 20,000, two 10,000s. The next higher would be 30,000. The midpoint would be 25,000. So 26,555 is a little closer to 30,000. So I would use that as my estimate. So subtracting 40,000 minus 30,000 would be 10,000. And when we're using rounding to estimate, we want to come up with numbers that we could easily do mental math on. So with all these zeros, all we're really doing is doing 4 minus 3, 10,000s to get 1,000, and the rest is all zeros. So this is very easy mental math. So this would be our estimate if we rounded to the nearest 10,000. And this is the easiest to do mental math because you've got so many zeros. So let's try a different place value though. Let's round to the thousands place this time. So this time we're rounding to this place value. Okay? So the 3,000 is going to, the 3 10,000s is going to stay there because we're starting to round with this number. We're rounding to the thousands place. So we have 5,000s as our low. Our next highest thousands would be 6,000. The midpoint would be 5,500. And we can see this number is a little bit larger than 5,500. So we would round up to 6,000. So this would be our estimate if we were rounding to the thousands place. And you see these two numbers are similar, but they're different. You get a different estimate depending on which place value you're rounding to. So this is rounded to the thousands. Also here we're going to do the same thing. We're going to round to the thousands. So we have 6,000. The 2,000 the two 10,000 stays the same because we're rounding to the next place value. So we have 6,000s. The next highest would be 7,000. Since it's 6,555, that would be a little bit closer to 7,000. So our estimate would be 27,000. So we have 36,000 minus 27,000, which would give us an estimated difference of 9,000. So again, these two estimates are close, but they're different. Let's do the actual subtraction. And since the ones, tens, hundreds are all the same, we subtract, we get 0. And we have 15 minus 6 is 9. So in this situation, our actual difference and our estimated difference are exactly the same. So rounding to the thousands gave us a more accurate or a closer estimate to the actual difference than 10,000s did. But the math is harder because we have 36 minus 27 now as opposed to 4 minus 3. So the mental math is a little bit more difficult in the thousands. And basically, the fewer numbers you change, the closer the estimate's going to be. In the thousands, we only changed 4 numbers. In the 10,000s, we potentially changed 5 numbers. But the math is easy. So you kind of have a trade-off there. But either way, if we got an actual difference of 9,000 and we compared it to an estimate of 10,000, we'd say, yeah, that's pretty close. I probably did my math right. So we can round to different place value digits, any place value digit that's in the number, and that will give us an estimate of whatever operation we're doing. Okay, let's move ahead to our problem set and try some of this out. So the number 1 says complete each statement by rounding to the given place value. So you have to make sure you check what the place value is we're rounding to, and then use the number line to draw to show your work. So we're looking at the number 53,000 and we're going to round to the nearest 10,000. So this is a place value we're rounding to, the 10,000s. So the low end of our number line would be 5 10,000s. The upper end would be 6 10,000s or 60,000s. And the midpoint between 50 and 60 would be 55,000. And if we put this number in, it would be 53,000. And so 53,000 rounded to the nearest 10,000 would be closer to 50,000. Okay, pause the video and you try 1B. Okay, again, we're rounding to the nearest 10,000. So this number has 4 10,000, so that's going to be on our low end. The next highest 10,000 would be 5 10,000s. The midpoint would be 45,000. 42,708 would plot about there, so it's closer to 40,000. Okay, pause the video and try C. Okay, and C, even though this number goes to the 100,000s place, notice it says we're still rounding to the 10,000. So we're rounding to this digit right here. So at the low end, we have 0 10,000s. So the number would be 400,000. At the high end, it would be one more 10,000. So we have 0 10,000s here, so one more would be 1 10,000. And our midpoint would be 405,000. And 405,000 is less than 406,000. So this would plot about here. So the closest 100,000, the closest 10,000 would be 410,000. Okay, we're going to go back to the top now to 2A, and notice this time you're rounding to the 100,000s place. So pause the video and try 2A. Okay, for 2A, we're rounding to the 100,000, so we have 200,000. The next highest 100,000 would be 300,000. The midpoint between 200,000 and 300,000 would be 250,000. And 240,000 would be about here. So it's closer to 200,000 than to 300,000. Okay, pause the video and try B. Okay. For B, in the 100,000s, we have 400,000. The next highest 100,000 would be 500,000. And the midpoint between 400,000 and 500,000 would be 450,000. So 449,000 would be close to 450,000, but less than. So if we round, we would round to 400,000. Okay, pause the video and try C. For C, we already have 900,000 on the low end. The next highest 100,000 would give us 100,000, which is 1 million. The midpoint would be 950,000. 964,000 would be more than 950,000. So if we round, our nearest 100,000 would be 100,000s, which we write as 1 million. Okay, moving on. Number 3. 795,462 songs were downloaded in one day. Round this number to the nearest 100,000 to estimate how many songs were downloaded in one day. Use a number line to show your work. So pause the video and give that one a try. Okay, let's draw our number line. And we're rounding to the 100,000. So in this number, at the low end, we have 900,000. One more 100,000 would be 100,000 or 1 million. The midpoint would be 950,000. 975,000 would be more than 950,000. So if we round, we'd round to 1 million. And again, whenever we have a number problem that asks us a question in words, we need to answer in words. So the questions were how many, the estimate of how many songs were downloaded in one day. So when we're writing about an estimate, we say about 1 million songs were downloaded in one day. We always answer a word problem with words. Okay, let's go on to number 4. This says this number was rounded to the nearest 10,000. List the possible digits that could go in the thousands place to make this statement true. Use a number line to show your work. So we see we're missing the thousands place here, and you're looking to find all the digits that could be in that blank to make this true, that this number rounded to the nearest 10,000 would equal 130,000. So pause the video and try that one. All right, it told us to use a number line, so let's do that. And we're rounding to the nearest 10,000. So we're rounding to the 10,000. So we're going to start here at the low end with 10,000. And one more 10,000 would be 20,000. Our midpoint would be 15,000. And so in order to round to this number to these 10,000s, the number would have, in order to follow this, it would have to fall in this range. So let's write this whole number . So we have 130,000 and one more 10,000 would be 140,000. And the halfway would be 135,000. So in order for this to round to 130,000, the number would have to fall in here. So if I put 130,644 or 131,644 or 132,644 or 133,644 or 134,644, I'd fall within this range. As soon as I went to 135,644, my number would round up to 140,000. So the numbers I could possibly put in the thousands place would be a 0, a 1, a 2, a 3, a 4. So the digits would be 1, 2, 3, or 4 could go in the thousands place. All those digits added here into our number sentence would make the sentence true. Let's go on to number 5. It says estimate the difference by rounding each number to the given place value. So we have 712,350 minus 342,802. And first we're going to round to the 10,000s, and then we're going to round to the 100,000s. Now, if it helps you to draw a number line, by all means do it. If you can visualize the number line and not have to draw it and still be accurate, that's okay too. So let's start with rounding to the 10,000s. So pause the video, round each number to the nearest 10,000s, and then get an estimated difference. Okay, for 5A, I'm rounding to the 10,000s. So 712,350 rounded to the nearest 10,000s. I have a 1 there, and then I see that the next is 2,000. So the midpoint, the next highest number would be 2 10,000s. So if I'm comparing 12,350 to 10,000s versus 20,000, it's closer to 10,000. So my estimate here would be 110,000s. So 710,000s, 350. But all these digits then go to 0 when we round to the 10,000s place. The second number is 342,802. And again, I'm looking at the 10,000s. So I have 4 10,000s. So at the low end, it would be 40,000. One more 10,000 would be 50,000. 42,000 is closer to 40,000 than to 50,000. So I'm going to keep this at 40,000. So it would be 340,000. So when I do my subtraction, my estimate would be 370,000 as my estimated difference. Now you're going to do the same thing, but this time you're going to round to the same two numbers, but you're going to round to the 100,000s place. So pause the video and try that. Okay, for this one, again, we're starting with the same number, but this time we're rounding to the 100,000s place. So I see I have 700,000s. The next higher would be 800,000s. But I see that 712,000 is closer to 700,000 than it is to 800,000. So rounding to the 100,000s, this would be 700,000. The second number, 342,802, rounded to the nearest 100,000. It's either 300,000 or one more thousand, which would be 400,000. But 342,000 is closer to 300,000 than it is to 400,000. So my estimate would be 300,000. And when I subtract, my estimated difference would be 400,000. So I have two estimates depending on, they're close, 370,000 and 400,000 are not hugely different from each other, but they're different depending on which place value I rounded to. So based on the discussion we had before, if we actually subtracted those two numbers, which one do you think, which of these two is a closer estimate of the actual difference? That's right, it would be this one, because I changed the fewest number of numbers when I made my estimate. But again, this would be very difficult mental math to do. You'd probably have to write it down, where this one's much easier. So you lose a little accuracy when you round to the highest place value, but it makes the mental math really easy. So again, if you had just solved this problem and you were thinking, those are a lot of numbers, I wonder if I did it right, you could quickly in your head go, well, this is about 700,000 and this is about 300,000, and 700,000 minus 300,000 is about 400,000. So if the answer you got is close to 400,000, you probably did the math correctly. So this is an easy, quick way to check your calculations when you're doing multi-digit operations to make sure that you got the correct answer. And that's the end of lesson 8.